Hi, everyone. We good to go? Yeah, I should turn around. I need to turn around. This is my first time presenting in Avatar Land. It's a whole different experience for me. I never even used to play World Cup. You've dimmed the lights. Wow, how romantic. Romantic's not the right word. What's my standard line from last time I was in Poland? Jest piękno kobietko. Masz piękne oczy. So the lights being dimmed just kind of works. Hi everyone, and welcome to SQLDay. I said I'd wear this, but I forgot to. So let me quickly. It doesn't really work with my. There we go. Last time I was in Poland for SQLDay, I got given this useful thing, which I'd worn at least twice. It was great when we had to wear masks, because I worked out how to put filters in, so it became my mask for a little while. But because we don't have any COVID cases here in Adelaide where I live, it's been fine. I'm at a client site tonight because I've got really good internet connectivity. But actually, I've been on a client site for months and months and months because, you know, we don't have COVID here. We've had a total of 4 people die from it in my state, which is about 1.5 million people. But the flip side of that is there's no chance of me getting vaccinated probably this year. So when you're all allowed to go to conferences because you're vaccinated, I'll still be just going, yeah, but we're not sick. So it's just a trade-off. Anyway, my name is Rob Farley, as it says down here on my Twitter handle. My email address, if you want to reach me, is this, and I blog here at my company website, but my company is mostly me and a few of my employees. So today I'm speaking about residual pain, and I don't have slides because I haven't used slides for some time now. It's not my style. However, I do want you to pay attention to all the other presenters that you're enjoying this week, especially the sponsor slides, as I think you can see here and maybe even here, or maybe here and possibly there. I forget, somewhere there are sponsors going through. Do go and chat to those people, because if you chat to them, they're more likely to come back and give some more cash next time the event's on. So please go and talk to them. Buy their products, at least pretend you're going to buy their products, and so on. It's really important that you do that for the success of an event. Anyway, I know some of you in the room were there when I presented 2 years ago in Wrocław. So I apologize for anything that you already know, but it's good to see some people come back, like Marek, who sat through it all day, and some other of my presentations too. You got lost. I don't know how to get out of this room. You can't leave. You were here for the previous presenter, and you just haven't worked out how Avatar Land works. You just hope that room C is the one you want to be in all day. I hear you. That's good. Somebody's talking in public. That's not something that I need to pay attention to, is it? Those were great workshops, somebody wrote. Fantastic. That I'm hoping that's about me. Might not be. I hope it is. I hope that public speak means here. I'm very worried about clicking anywhere on the Avatar Land window in case it suddenly walks me off stage or something like that. It's bad enough to know that I might accidentally dance or something like that. It's just kind of odd. That's not me. But yeah, and it's very strange to see myself doing that. Anyway, I couldn't make an avatar that looked really like me, so I think instead I look a bit like Mladen Prodigy, but I'm not really sure. I can't tell. I did try to match the color of my shirt today. Anyway, so we've got about 50 minutes to go, so let's jump in and do proper content. I want to talk about residual pain, because way too often, as Hugo knows, and I'm going to use Hugo for examples because he presents about execution plans and stuff like that, and so he totally knows. way too often you'll look at an execution plan and you'll go, well, yeah, that should be working nicely. Yeah, that should be good. And you may not pick up on the fact that there is extra work going on that you may not have noticed at first glance. Okay, and a lot of that comes down to residuals. Sometimes these things are called residuals, and sometimes they're just actually called other things, but essentially they mean the same thing, and that is that that the main thing that it's having to do isn't doing the whole job. It's having to do extra checks, right? So the main things that I want to be looking at today, I'm going to be mentioning seeks. I apologize for my writing. I'm writing on a screen which is at an angle. I was tempted to flatten it down and all that kind of stuff, but then I found it was strange for trying to look at the Avatar Land window and the one that is being shared and so on. And I'm drawing on a window that's over here, and that one is anyway. So I'm going to look at seeks. I want to look at hashes. I want to look at merge joins. And there's a few things in here that I kind of, in fact, in some ways, I want to be able to consider that seeks becomes a bit more complicated again, because in some ways I feel like lookups and so on almost counts as being residual like. So I want to cover some of these and explain what goes on with residuals and how you can actually wind yourself in a whole bunch of pain if you're not conscious of the fact that the residual is going on. And I'm going to do all of this without Management Studio, without any actual execution plans. I'm going to do it all just through the joy of diagrams that look like this. Okay, it's fine. If you hate it, you can leave. I won't mind. I get that my style is not for everyone. To be honest, I might not even notice if you leave. Somebody already has. It says 18 people in the room. I do love the fact that, by the way, that the Polish word for room is sala, one of them. And because last time I was in Poland, I was in room D, and so it said that it was salad in the room, and I thought that's nice, lettuce and so on. That's good. Salad's healthy, good room to be in. This time I'm in salak, and it doesn't quite work so well. It's probably salats. Anyway, so yeah, so it's nice to be. So somebody's already left, and I don't know who that is. If one of you leave, that's fine. I might notice if it's Hugo or Marek or my tech. The rest of you, I probably won't know. And certainly I don't mind, because I know there is a lot of good content going on. So, residuals. You understand that if you have an index seek, right, that's producing so this is a seek here. If you have a seek operator running and it's producing like a single row, right, very thin arrow coming out of it, right, that's a good thing, right? You know this. You know that basically a seek that's finding a single row is a good thing, right? The pain is in how much work is it having to do to find that one row, right? Now, in case you're kind of unaware, the concept of a seek is that we have ordered data that's stored in an index in this ordered way. It's not necessarily physically ordered, but it has enough pointers and so on to know how to get through the data in order. And just like with the phone book and so on, it can figure out which section to go into and so on, and it can move through a B tree of the data, figuring out, well, hang on, I've got to go I've got to go to this page, and now I've got to go to that page, now I've got to go to that page to figure out where the row or rows are that it needs, right? And the logic that it's using for that is in the seek predicate. So, for example, back in the days when we had phone books, which seriously, kids these days, I think people probably, anybody younger than Marek, probably doesn't even know what a phone book is. It's a really bad analogy because seriously, it's disappearing pretty quickly. Kids these days know that they just type straight into their phone and the name comes up. They probably don't even type it in. They probably just speak to it and say, hey, call Hugo. And it goes, yep, we know. That's fine. But if you're looking for Hugo, just curious, does the light bulb mean does the light bulb mean that somebody's got a question? Does the light bulb mean, Patrick, what does the light bulb mean? Pavel saying same as the floppy disk icon. Yes, totally the same as the floppy disk icon. They don't know what that means these days. Kids are they're just way too ignorant. But yeah, you can imagine though, right? When you've got a phone book, when you've got a series of phone books, like, you've got like A to D and E to K and L to P and Q to Z or something like that, right? And you've got those 4 books. You straight away go, okay, I'm looking for Hugo Cornelius, and okay, yep, A to K is the one to start with. This is the same as the idea of traversing through a series of levels of an index to find the stuff that you want, right? You can go, and it does it simply by going, okay, this one starts with A something, this one starts with L something. It goes, hang on, no, the A one is the one that I want, right? It actually does a binary search to find that, so it's probably going to start in the middle and work. It works. It manages to figure out pretty quickly which, and I've got to make sure I don't kick the table that I'm sitting at because I'm in a side room and it's got a small table, and if I touch the table, the camera is on a screen and so on. Probably, I apologize for that. So you can move through because you know that the data is ordered, right? I know that if I found the row for Cornelis, then it's there in amongst all the other ones that start with a K because it's ordered data. I know that I don't need to go and look in the Q to Z book just in case Hugo's row is in there, because no, he's in the what did I say? It was E to K book, that one. So it's the same, but it relies on having ordered data. Now the seek predicate, your seek operator will have a seek predicate that helps it figure out what it's looking for in the ordered data, right? So they can figure out, okay, yeah, this is the start of the ones that I want, right? However, seek predicate might not be it might not let you find the exact set of rows that you need. There might be other things that you've got to figure out. For example, if we're looking for anybody called just Hugo K, then our seek predicate is going to go, yep, it's between K something and not yet L something. So the seek predicate is only going to find the ones that start with K. It's going to be a range in here, right? It's going to be a whole range, but we only want the people that are called Hugo. So we have to start at the beginning of that range. Let me draw. We can dive in and find the beginning of the Ks, but then we have to start looking through, checking every row we come to until we get to the end of that range, until we reach the one that starts with L, or no longer starts with K at least, right? And to be able to check all of those, I've got to hold my hand in the right spot. To be able to check all of those, we have to do an extra predicate, right? So our seek operator will have a seek predicate, but it'll also have another one that's just called predicate, right? Now, I call this a residual predicate. And in fact, other people who have worked within Microsoft and so on also refer to it as a residual predicate, but it ends up just getting called predicate within the seek operator. It's really annoying that it does that because because I would certainly like it to be called residual predicate, but it's not. We've got the seek predicate and predicate kind of stuff, but it is what it is. You know now, because I've told you, when you see it say predicate, that it means residual predicate. It's having to do extra work to be able to figure out the rows that it needs to return, right? And I complained to Microsoft for ages about how painful it was to be able to find, to see what the impact of that was. And so in about 2015 or maybe 2014 even, they added a property to a seek operator which says the number of rows read. And that tells me the size of this range that it's having to look through, right? Number of rows read. And because that might be huge. But if it turns out that we might be looking through thousands and thousands of people who start with K, but there might only be a handful called Hugo K, and those are the ones that get returned out of the seek operator, right? And it doesn't push it. This operator here is saying, hey, give me a row, give me a row, give me a row. And it's having to work them out. But it's looking through the range, and as it finds the ones that also satisfy the residual predicate, it spits them out, right? Thing is, when you just glance at your plan and you go seek, producing a single row, nice thin arrow, you go, hey, that's great. Unless you notice that there's residual pain going on, right? Now, SentryOne's Plan Explorer will put a little warning on there and say, hey, there's a whole bunch more reading going on than returning. We're eliminating a lot of stuff through the residual predicate. And it is worth considering what the impact of what the selectivity of that residual predicate is, because you might even want to change your indexing strategy so that you can figure out a way of producing those. If we actually typically have to look for people by their first name and surname initial, then maybe we want to actually store that in a different way, like index it in a different way. Maybe we want to have an index on first name, comma, surname, so that we can actually more quickly find all the Hugos and continue to seek to find the ones that are the Hugo Ks, because they'll all be together, so that we don't have to read a big range. We can seek to find quite a narrow range. Worth bearing in mind, because there's residual pain by having to check through more stuff. Another thing that I said I'd mention as well about seeks is the pain that you get when you simply don't have enough columns in there. And what happens here is that you might have a lookup going on. Okay, I'm just going to put an L in here, which means that every row that comes out of the seek requires a whole bunch of more work going on to do the lookup, to either check some other column or to return other columns. And you can often find that is way more work than you're expecting, because your seek here is doing some amount of work to go through the data and figure out what it's got to return. But then for every row that comes through there, it has to go and do more work. There's the whole tipping point thing where it goes, you know what, that's going to be too much effort. I may as well just use the clustered index instead and probably scan it. And that can be really painful. But I still feel like it's a form of your index isn't good enough. You need to fix your index and make something that actually works for your query. Because it's a real pain when it thinks that it might have to do that tipping, when it's reached that tipping point. Because it might even be thinking that it's reduced to hit the tipping point, but it hasn't, and because of out-of-date statistics, things like that. And try and get rid of your lookups. But one thing that I'm also conscious of is when I'm dealing with column store indexes, because column store indexes, like in a column store index, you're scanning the index, you're looking through a single column probably for the stuff that you're interested in, looking for the most selective one initially, but then having to look through other ones and try and figure out what the combination of those things are, get what you need. And if you're selecting extra columns as well, you might have a lookup in there and it doesn't really have an option to be able to hit a tipping point and move across. And quite often that extra work that needs to be done the residual predicates, but also that lookup that needs to be also done can be way too much work to make your query run as well as possible. It's frustrating. But sadly it's the way it goes, right? So yeah, seeks, they're great, except that at first glance you might not be able to spot how much work's going on. If you're using a much older version, then you used to be able to use a trace flag on the query called 9130. And this would actually mean that the residual work would be done in a separate operator here. So this would actually return the whole range, and then the residual would get applied in a filter here in the middle. And that was really convenient, except for the fact that, you'd get more complex execution plans than you might like. And it meant, turning on a query, it meant turning on a trace flag using query trace on when you wanted to see that behavior happen. Way nicer what they did to be able to produce the number of rows read property of that operator. So make sure that you look for that. Get used to checking the properties of operators. In fact, when you're looking at execution plans, just hit F4 and have the properties pane there on the side so that you can more easily look at it. Because it's all well and good to be seeing the values in the tooltips, but really you find that as you're starting to look at the ones that you commonly are aware of, being able to have them there in the properties window is very, very useful. So yeah, seeks. I said I'd look at seeks. The next one I want to look at is a join operator where we've got data coming from somewhere and data coming from somewhere, and there might be other stuff to the right, I don't really care. But the join operator that we've got here is a hash, right? Now, let's talk about how a hash works, and then we can see where the residual fits, okay? How a hash table works is that typically with a smaller set and a larger set, but either way, and there's interesting things with bitmaps that I don't really want to get into and so on, but nevertheless, this top flow of data is pulled into the hash table and into the hash operator, and the hash operator creates a hash table. It means it applies a hash function to the things that it needs to join on, using it has to join using an equality match on, and then uses that to be able to apply the same hash function to the join columns on the second side, and anything that is going to be an exact match, the hash of that is going to match the hash of that, right? It's what it does. Basically splits the data up into buckets so that it can come through and just go, okay, I've got some stuff here, I've got some stuff here, I've got stuff here. Where's it going to go into which buckets? Okay. And it puts that into buckets, into an address size, which is 32-bit big. So it's got like 4 billion possible buckets that it's landing things in. But what can happen is that it has to check to see if 2 rows that are landed in the same bucket are actually a match or not a match, right? Some of that comes down to the bucket size, but sometimes the things that it's joining on just aren't really selective enough. Let me show you what I mean. I say let me show you what I mean. I'm not going to run any actual queries. I'm going to describe some scenarios. Now, imagine that I've got. Imagine that I'm joining between a string value from the top here with a string value from the bottom here. I don't want to have to, me as the query optimizer, when I'm running the query, I don't want to have to try to say, does this person's name match that person's name for every single one, right? Especially since some some of the data that I might be joining, I might be really quite long. And it's a pain to have to go through a whole massive amount of data and see if it's the same as a whole massive amount of data there, and store all of them as well to be able to see how it's going and so on. The storage is another question. We end up still having to store a whole bunch of stuff. But what it does is that it says, I want to apply a hash function to that and then store what I need to do to be able to do the extra checks in a hash table somewhere, right? In that 32-bit address space. So if I'm trying to figure out whether Hugo Cornelis is the same as this other person called Hugo K, then it applies a hash function to Hugo as it comes in from the top flow of data, and it says and it puts it into a bucket according to the value from the hash function when applied to Hugo's name. It does all of that for everybody's names that are coming in, and then when it sees the data from here, it goes, oh, okay, let's apply some hash functions so that it can then go and check and see what it actually matches according to the fact that it landed in the same bucket. Now, thing is that there's no guarantee that somebody who is not Hugo, that their name might not land in the same hash bucket as Hugo's. You understand, right? Like a hash function is just a function that spreads the data out far and wide and so on, so that it's easy to read, all that kind of stuff. It's a nice mathematical thing that it does, but there's no absolute guarantee, especially, well, in fact, by definition, there are more than 4 billion possibilities of names, and so therefore you're going to get some clashes somewhere, and it's going to have to make sure that they are that it's not clashing. So having worked out some things in a bucket along with some other things, it has to check each one that's in that bucket already to see if there's some more work. So this phase here is called a build. This phase here is called a probe because the hash table is complete, and we've got some value, and we're needing to probe into the hash table to see what's in there for this one already. But then we have a probe residual, which sounds kind of icky to me, but anyway, we have a probe residual that checks to see, does it match everything else, anything else that's in the hash bucket, or have we got to consider something else that's going on, right? Like, if it doesn't match anything in the hash bucket, it's not a match, but it wants to check those different values. It doesn't want to check all the values. It just wants to be able to check the ones that are in that bucket, right? Now, with names, probably things are pretty well distributed, but because it's only probably, it still needs to check with that probe residual. But there's some things you can do to help. If the probe residual is selective, but actually the things that are the probe keys are not, you'll find that lots of things are landing in the same buckets. I've seen scenarios where there's only like 20 hash buckets going on, but each one is getting like 1 million rows in it. And so inside that, it's having to do a ton of work to try and figure out what's actually a match or not. And it would have been better to take the 1 million values and use that as the key, and then have a probe residual on the 20 different things, right? Being able to make sure that your seek predicate, remember in the seek predicate is as tight as possible, so that you're not having to check a whole bunch of things residually. You also need to make sure that your hash buckets, so you have as many of them as possible for the sake of your query, that's what's selective, rather than the residual doing all the work. The warnings about that are not so huge, but hopefully you know your data and you can spot the fact that are the keys selective or is the residual selective. Okay. There's one trick I want to mention with hash tables, and that's the fact that how I said it was a 32-bit address space. 32-bit is the same size as an int, right? With a little caveat. Hugo, are you listening? Raise your hand if you're listening, Hugo. And if you are, I'm going to ask you a question. You are. Fantastic. Hugo, and I'll get Patrick to, or Martin, my tech. I'll get him to be able to unmute you. Hugo, do you know what the caveat is about an int? Oh, you can. Fantastic. Hugo, do you know what the caveat is for an int in a hash table?
The fact that it's nullable makes it 33 bits instead of 32.
Fantastic. We got a 32-bit address space which matches an int, but as Hugo correctly points out, I'm so pleased. Sorry to put you on the spot there, Hugo. I was just kind of curious. Sure, you mentioned this in some of the stuff you've written about before and presented on and so on. But if your int is actually a nullable int, then it's not 32-bit, 33-bit, because it's got an extra one to say, oh, actually, it's unknown. Really annoying. You don't have just 4 billion different values possible. You've got 4 billion and one. Personally, I just wish that they would make it go from, whatever it is, 7, the 2 billion and some 7 at the end, on both ends, positive and negative. Instead, it goes from negative, blah, 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 and it ends at an 8 because they have that smallest value. I wish that null worked out to be that, and that actually it fitted inside, still nullable version, still fitted inside a 32-bit address space, purely for the fact that way too many systems define columns as null without even thinking about it, including integers, and then join on them using hash joins, hash matches, and therefore have the extra work of a residual to go on. Because if it didn't, it could just go, yep, this one matches this one, and there's no chance of it clashing. But instead, the nullable one clashes with another value. It's crazy. But at the end of the day, that's how they defined ints, and that ain't going to change. It's just really sad. The way to get around that is, please, and I'm leaning into the camera to implore you, make your int columns not nullable. Otherwise, you've got extra work going on, and every time you've got a hash match, because it just goes, oh, look, 3 is the same value as 3. And let's just check that it is. And you can test this. You'll see a hash match going on. Make both sides not nullable, and you'll see that your probe residual will disappear. It's fantastic. It's terrific. It cuts down the work just a bit, but it's nevertheless, it cuts down the work. Cutting down the work is, useful. Anyway, one of those things. Way too often you've got probe residuals that are just doing too much work, and it's kind of annoying, right? So yeah, hash matches. They're surprisingly effective. Like surprisingly effective because they feel like they're slow quite often. And quite often you can figure that there's a nicer way of doing something without using a hash match. And they typically they block for a while it's building the building the hash table. And there are smarts in there where it can actually switch around which one's build and which one's probe and so on. They've done a lot of work in recent years to make hashes better than they are. But it's still a thing. It's even a thing in the scenario where you have a hash aggregate, right? When you've got, I should write better than that. When you have a hash aggregate, you've got a hash aggregate going on. You've got data coming in and you're needing to do group by, and it's not ordered data, so you're doing a hash aggregate instead of a stream aggregate. Stream aggregates are so much nicer because you've got ordered data coming in And it can just look through and just go, yep, that's changed. So I know that I'm not going to see any more. I know when I'm looking through the phone book that if I've seen everybody who's up, hey, I'm not going to see another one. Definition of ordered. So it doesn't need to block anymore. I can say, yep, and there were 17 of those. With a hash aggregate, you don't know any of the answers of how many you've got or what the sums are of some column or whatever until you've seen all the data come through. Because Murphy's law is that if you were to try and spit one out, then the very last one that comes out is going to be changed. They can't do it. They have to see all the data before they can give any rows with a hash aggregate. Kind of annoying. If it's doing a hash just for the sake of a distinct operation, then it can do a distinct sort, and just every time it sees a new value that it hasn't seen before, it can spit it out. But an aggregate doesn't get to do that. It has to see all the values to be able to count them or max them or sum them or something, right? And again, these buckets might have to do too much work within each bucket, trying to differentiate between the different groups. It's nicer if you see a hash aggregate, be able to make sure that the things that you're grouping on don't require a whole bunch of extra work. Anyway, that's just a quick thing there. So the next one I want to talk about is a merge join, right? Talked about seeks, talked about hashes. I want to talk about a merge join as well. See, and every time I start writing, I think to myself, this would be nicer on a physical whiteboard, because on a physical whiteboard, my writing is not normally too bad. But anyway, it is what it is. So, merge join. And frustratingly, because I'm writing here, I keep doing this because that's where it looks like it is to me. And then I've got to go, oh, hang on, that's right, over here. Merge join. With a merge join, as I'm sure you know, but if you don't, then let me teach you. You've got data coming in from two ordered sets of data, right? This set of data is coming in and this set of data is coming in, and they both have to be in the same order, because the way that it works is to be able to progress through the data in order, moving through the data, looking for the matches, right? Now, so this means that it'll be like, so this means it will be, it'll be moving. Sorry, I just got a text message from my mother-in-law. Anyway, all good. I'll sort that out later. It's the problem with it being evening here. It's like 6:30. Anyway, so what happens is we're doing a join and we say, okay, yeah, we've got a value 1 here and we've got a value 1 here. Hey, that's a match. And then we move on to and then we see do we have any more ones as we go down here. And then when we're done with the ones, we go, okay, let's move to the next one. Maybe the next one's 4. I don't know. And this one says, oh yeah, I've got some 4s. Then move on to the next one. And this one skips past as many as it needs to, and it moves through the data on each side, figuring out what's a match and what's not a match. Now, this doesn't care at all about the 32-bit address space. It's just looking at ordered data, being able to go, yep, I've seen you. And it sees what it can join against, and then it's being like, yep, I don't, once it moves on from that, it doesn't need this stuff anymore. It's done. And it's great. You can have massive amounts of data, and you can move through it very effectively with a merge join because it's ordered. Ordered data is huge. Seriously, the big impact of indexes is not it helps you find the data easily. That's a thing. But actually, think about the fact that it's ordered data, which means you can quickly get to the ones at the top. You can quickly do joins between them, and also it helps seeks because you can find the rows that you want. But understand, ordered data is what it's all about. That actually helps you plan whether you need a composite index, all of that kind of stuff. So a merge likes order data makes it very powerful, right? But there are two hidden ways that merges can be expensive, right? The first one is the standard residual predicate, and at least this one, it calls it a residual predicate. The thing that it's doing the main join on, it actually calls itself as the where join columns, right? In the merge join operator. And that's the thing that it's going, yeah, it's ordered by these. I know that I can merge on these, and it's good. It can join on these, right? But the thing is that there might be other predicates involved, and sometimes the things that it decides to do the join on is not particularly selective. There might be heaps of them on one side, or even on both sides there might be heaps, and that's the second thing that I want to talk about, but I'll come back to that. It might be finding that that it's a lot of work to do that first join, and then all the effort is in residuals. The idea being, if I've got a 1 here and there's like 50 ones on the other side, and then I'm only interested in one of those, or two of them maybe, but I'm filtering out them because of a residual predicate, something that says actually the join is not just 1 against 1, it's 1 against 1, and it's got to be Hugo and Hugo. Sorry, Hugo, I'm using you as an example again. I apologize. It's just because you're here. I hope it doesn't. I hasn't put you under pressure to stay.
No, it's okay. It makes me feel very important.
You are very important. There was a time when I was giving a talk about windowing functions, and ITSIC was in the front row, and that was interesting. I think I'd been an MVP for about 3 weeks at the time. It was back in 2006, and ITSIC's in the front row, and I'm talking about windowing functions, and that was, and I started to use him as an example, and I said to the room when it all started, and by the way, ITSIC's in the front row. He's the guy about windowing functions. I didn't know he was actually going to be here when I submitted this topic, but he's there, very front row in a lecture theatre. He's like all of 5 feet from me, and I'm presenting about his topic, and everybody else in the room would probably be rather listening to him talk about it than me. So, but and so then I was just like, so a bit strange with him here. So I said, so ITSIC, if you have any questions, just feel free to ask. It's fine. No pressure. It's all good. And everybody laughed and we moved on. But then he told me later he felt like he couldn't leave because I had mentioned him and so on. So if you need to leave, it's fine. I understand. I'll keep using you as an example. I will just probably, talk more about you if you leave. Let's go with that. If I found that 1 against 1 is what it's joining on, but then I've got a whole list of people and a whole list of people, and the row that I wanted to join on is 1 Hugo, and I've got 50 ones, and only one of them is Hugo, I'd rather be joining on the names where probably, Hugo matches with Hugo, great, and they're probably both number 1. If it's Hugo, he's number 1. But understanding the selectivity of those where join columns in your merge join compared to what's going on with your residual predicate. And it's great that it calls it a residual predicate. And I even wonder whether it's called just a regular predicate in a seek because they had already used the residual predicate property in the merge join. Maybe it's just I don't know if that's true. It's just my guess that maybe it could be. But having a look and seeing, is the work being done in your where columns or is the work being done in your residual predicate? Because if the work's being done in your residual predicate, that's bad. And I've seen scenarios where well-respected authors about windowing functions and so on have been stumped by the idea of, hang on, why is this query slow? Because they hadn't noticed the fact that all the work was being done in a residual predicate. And I mentioned the windowing functions thing because it was in a post that somebody had done about windowing functions, and it had the best thing for it to have in the where bits was the rank, the row number that it was joining on, but instead it was doing it on a different column. And so it was doing it on a different column, but then it had like hundreds of row noms, which would have made much more sense to be doing the where on. And so they managed to, they tweaked the query to make sure that the row nom was noticeable as being more selective than the main thing that it was looking at. The thing that it was joining on was fairly selective, but not nearly as selective as the row nom as well. And being able to persuade it helped. And that persuasion was also, it was done by like putting indexes on, so they didn't need to think that it had to sort, be able to handle it better and so on, and they could just make the data flow much more nicely into here, and the residual predicate became next to no work, and it worked generally quicker. These are the kinds of things you need to look for in a merge join. But that other one that I mentioned is the many-to-many property of a merge join. Now with this is where you go, okay, I'm joining on the 1 to 1, and and then I'm moving to number 2, and I'm seeing, are there any 2s there? I'm moving to the next one, might be 4 or 5, and it's seeing, there's some there, right? But the thing is the fact that if there's a possibility that it might see another number 4, then on the second side, it might need to go back and do that again. I should be using the yellow hand, shouldn't I? This is the side. This is the first side. No, this is the first side. Yeah, this is the first side. This is the second side. I always forget about the whole. It's mirrored so that I can interact with the screen here. I'm mirrored, like, yeah. You can see from my hands. This is my left hand, but it looks to you like my right hand. I think maybe yeah. So you're moving through the left side, thinking about what's on the right side, but actually it's more like top and bottom. I'm moving through this data and I'm saying, okay, yep, here's the block that's for this one. And then here's the block that's for this one. And if it's not many to many, I can just be like, yep, I've seen all of these and I know that I never need to go back in my ordered data. Move to the next one, I can just keep moving through. But if it's many to many, then you might have repeats on both sides, which means you hit 4 and you look at all the 4s, you might hit another 4. Which means you need to go back to the top of the 4s and go through them again. And that is background pain that is really annoying in a merge join, right? It means that it's having to do a whole bunch of extra work to be able to store that temporarily and then to be able to go back to the top if it needs it. If it's a different value, it just goes, cool, I don't need that anymore. Let's move on to the next block. But the fact that it has to store it the whole way through is really frustrating. And the way that you solve this is to make sure that the system knows that that side is unique. You can do that in a variety of ways. You might do that through a unique index. You might do it through a group by. You might even use the word distinct. But anyway, let's not dwell on that too much. But being able to, and in fact, you might control it with a subquery, right? My preference is a unique index because that way, yeah, it's good. But actually, you can do it quite effectively with group by or even distinct, because then you might be able to just kind of have like a stream aggregate coming through because you've already got sorted data, right? So the idea here is that if you've got, well, hang on, let me shrink the size of this operator. I'm going to make it a bit tighter. So we've got ordered data coming through here, right? Ordered data coming through, right? And then if we hit a stream aggregate that is really just doing a distinct operation here, right? The impact of that is that this becomes one to many instead of many to many. Then we can help that merge join really, really effectively, right? I've seen scenarios where it does the merge join and then it does a group by much later on down because the person's involved something else from this side in the group by and so on, and it's just not as elegant as it should be. But you know your query and what it's trying to do. And if you've got this data coming through and your goal is to get that to be one to many, and you know that you can, then being able to make a subquery distinct or group by, or depending on what you're joining on, right? Making sure that ideally it's grouped by the things that you're joining on so that it knows that it could be one-to-many, or a unique index so that it knows that it's unique on those columns that are involved in the join. And you can see some massive behind-the-scenes backgrounds of your in your execution plan. I mean, because the basic concept here is that when you see an execution plan and you've got some joins going on and you've got some other things going on and other joins going on, all that kind of stuff, at first glance, this might seem like it's amazingly wonderful. You've got thin arrows, you've got seeks and stuff like that. Terrific. It might feel really good at first glance, but you need to know to go and check various properties to see, is my range scan of my seek doing too much work, and it's got a number of rows read higher than the number of rows returned. You know, understand that concept. Understand about hashes and being able to figure out what's actually going on with the hash table that you're building. Is it doing too much work inside that? Have you got lookups going on that you could get rid of just by having them included in some other index? And what's going on with your merge joins? Do you have many-to-manys going on that need to do a whole lot of work behind the scenes to make sure they can go back again? Or is it doing too much work with the residual predicate rather than in the where join columns? But yeah, I hope, as we're running out of time, that this has given you some clues as to where to look inside your execution plans for hidden background, leftover pain, residual pain, the stuff that's going on that is behind the scenes, that's the leftover work. Once it's done the seek, what else does it have to do, and so on. Okay, so yeah, residual is the key word in hash matches and in wheres, but also I feel like relates to just any time that your first impression of what's going on is not the whole story. So feel free, any of you, to unmute and ask questions or to make comments. But please remember, there's no such thing as a stupid question. It just means that I probably haven't explained it well enough. You're all very silent at the moment. And Hubert's joined the room. Get Hubert. But he's I think he's his great session. I don't think he was in here the whole time. Hugo was, I believe him. But I think he's just being polite. Hugo's even clapping. How about that? I so wish I could hang around for more of SQLDay. I mean, time zone wise, it's a real pain. I would have liked to be part of the panel they had yesterday, but I think I was asleep by then. And you know, it's 10 to 7 p.m. here, so I need to be heading home and seeing my family and eating tea and all those kinds of things. Dinner, you call it. Kolacha. I always mix up kolacha, which means dinner, I think, right? And koshula, which is shirt. For some reason, I always type the wrong one when I'm trying to pretend that I speak little bits of Polish. But as I was saying to somebody earlier, mówienie po polsku jest bardzo trudne, so I don't try too much. Duolingo says that I'm better than I am polite. Yes, so Katarzyna has she says she hopes to see me offline on the next SQLDay. Well, in that case, I hope it's an in-person event, and that you don't just mean that you hope that it's an online event, but that I'm offline. I think I know what you meant, but yeah. It's okay. I know what you meant. It was, it's good. I think that what you're meaning in the chat is that you shouldn't eat your shirt while dressed for dinner because koshula doesn't taste good for dinner, and I'm inclined to agree. The annoying thing is when I've had lunch and I've got some food on my shirt from earlier, and that's. But if that's for dinner, then I've got problems. Hey, I'm guessing that there aren't questions, which either means that you all fell asleep, or that I was giving information that you already knew, or maybe that I explained it so well that you all understood everything and don't have any questions. Let's go with the last one. And actually, no, I actually hope that it's all stuff that you already all knew, and that it was just ringing bells with you, and that you're just like, yeah, I'm just here for the jokes. And that's and that works for me. I know that Hugo didn't learn anything at all, except for the fact that I draw on the screen while presenting. But yeah, I only have the one session. I was going to be doing a workshop earlier in the week, but I didn't have good numbers and it got cancelled. But this weekend at Data Weekender, I'm giving a presentation about giving presentations, where I'm going to be talking about why I don't use PowerPoint and how I try and engage with the audience. So go along to that. It's free. But I got to say, I do love this whole Avatar Land thing. I like the idea of being able to see there's a room with fake people, but with names above their heads and so on. I like the fact that I bumped into some of you around the world, the Avatar Land world. And I really wish that time zone wise, because I'm in Australia, nighttime here, I really wish that I could just spend more time wandering around chatting to you all about nothing. But yeah, and by now, since numbers are going up, I think you're here for the next session. I don't remember who the next session is, but I'm going to wish you all a tremendous rest of the week. As per last time, jest no kobietą, masz piękne oczy. I hope you enjoy the rest of the week. And thank you. Big thanks to Hubert and all of the other organisers and sponsors for helping make this happen. Without you, the world would not be such a good place. Thank you all. Gonna stop sharing my face now. Or have I already? No, you can still see me. Oh, I need to stop the Zoom session. I need to leave Zoom. If I can figure out how to do that. Here, stop share. Okay, so I stopped the share. My tech person, hey Matson, is there anything else you need me to do for the Zoom session? Well, that's all good.
Yes, right.
So we're good?
Okay, right.
Nothing more you need me to do. Fantastic. I will leave the stage. And in fact, I will end up closing Avatar Land now. I will wave to you all. I know, give me a second. I'm trying to get the wave button. Wave. There we go. Thank you all for coming. I will see you again at an event, and I hope to see you in person next year or whenever they let Australians leave Australia. Thanks, everyone. Bye-bye.